I'm Scott Ramsay, and I'm an associate professor teaching stream. Background on me, I did my undergrad at UBC in Vancouver. I did metals materials engineering, it was called back then. And then I did my master's and my PhD out here at U of T in, it was then called IPBME. It's biomaterials and biomedical engineering. And I worked on a project where we were making a biodegradable material for fixing broken bones. A lot of my teaching is in first year, so I teach the Intro Chem and Material Science class, and then I've taught various different courses in the upper years. The course I teach now is MSE 398, and that's manufacturing and design class. So that was actually really fun. Students get to work on a project, designing and then actually building a prototype essentially of their design. I was fortunate going into the pandemic in a way that I actually had a lot of online content prepared already. I started working on a little light version of a textbook a number of years ago. I had it on this online platform, Top Hat, and I sort of tested it out with students a number of years ago just as a supplement. A lot of students they seemed to really like it, and they were asking if there's additional chapters and stuff, and I hadn't written them yet, so I wrote those. And then it kind of just shifted to that being, it made sense that was the textbook that we'd use for the course, because the course is a little bit non-traditional in its sequencing of topics. And so it's frustrating with a traditional textbook for students to jump, you start with chapter 6 and then you move to chapter 2 and so on. So with the textbook that I've written, it follows just exactly what the students need to know for the course. And then it's got these videos, about 10 minutes each, of me explaining little topics that are embedded in, along with questions that the students can sort of gauge their progress through the course. My sort of style or approach to teaching is, I really enjoy doing lecture demonstrations. I mean, these days there's so many distractions that our students face, right? I see it as kind of my responsibility up at the front of the class to keep their attention. So I know if what I'm doing at the front of the class is not sort of more engaging than the other things available to them, then I'm going to lose their attention and they're not getting anything out of it. So I almost view it like, and I know some people will sort of shudder, but almost like putting on a bit of a show. You try to keep the energy up and keep things engaging. And I think the thing that's nice about that is that they're memorable, and I really hope that they convey some of my own passion about the materials. Because years down the road, when someone's working as an engineer, they won't necessarily remember the crystal structures or even dislocation movement or something necessarily, and if they remember that excitement that, hey, there's solutions exist and I can probably figure them out, I think that's a really positive takeaway for them. If they're getting excited about the material and they know that there's a huge potential in the subject. I mean, advice to students. Well, the best answer I have is to study something that you're excited about. If you find the subject matter interesting, it's not going to feel like a chore to study it. If that means you transfer into MSE or into another discipline, if you're in a place where you're studying stuff that's interesting to you, that's where you want to be. And then beyond that, focus on your academics first. Obviously, you need to take care of your own mental health and do those other things that keep you happy and healthy. But if you come out of your degree with really strong grades, there's so many doors that'll be open to you. Again, keeping your own mental health in mind, prioritize your academics. I think that's going to be a wise approach.